Okay, so for Geometry Fundamentals, we're going to take a look at lesson 6.4. These are on rhombuses, rectangles, and squares. So these are all special types of parallelograms. Remember, parallelogram has opposite sides that are parallel. So let's take a look at the first special parallelogram. This is a rhombus. So this is a parallelogram with 4 congruent sides. So you can see here, 1, 2, 3, 4. All the sides have to be congruent in order for it to be a rhombus. Rectangle. Okay, so this is a parallelogram with 4 right angles. So if we have a parallelogram and there are also 4 right angles, it has to be a rectangle. And lastly, we have a square. This is a parallelogram with 4 congruent sides and 4 right angles. So if you think about combining the definition of a rhombus and a rectangle, you get yourselves a square. So we can see all 4 sides are congruent, and we have to have 4 right angles. We have to have both of those two in order for it to be a square. And just keep in mind, if you want to pause it, if I'm going too quickly, you can pause it. Also, you can try the problems and, pause it and check your answers as we go. Okay, this is a rectangle. So that means all the angles are right angles. Also, because a rectangle is a special type of parallelogram, that means opposite sides are congruent. So if BC is 5, AD is 5. If DC is 8, AB is 8. Okay, so sometimes it's helpful to look at the picture and figure out what parts are congruent. Remember, with parallelograms, it's always like the opposite sides are going to be the same. Okay, so on the left, AD, so AD we said was 5. AB here has to be 8. And then for all of those measures, measure of angle A, measure of angle B, measure of angle C, and measure of angle D, we said these are right angles, which makes them equal to all 90 degrees. Okay. All right, next one is a rhombus. Okay, so again, the definition of a rhombus is that it has 4 congruent sides. So all 4 sides are congruent. Well, notice PQ is 6, so that makes each side also 6. So QR is 6, RS is 6, and SP is 6. Okay, these are just really, it says corollary. These are just the converse of what we said before. So if we know it has 4 congruent sides, then it has to be a rhombus. And if we know it has 4 right angles, then we know it has to be a rectangle. And if it has 4 congruent sides and 4 right angles, then it has to be a square. So sometimes we want to be able to identify what type of parallelogram or quadrilateral we have. Okay, use the information in the diagram to name the special quadrilateral. So again, we want to call it a rhombus, a rectangle, or a square. Okay, if we look at the first one, well, I see 4 right angles, but the sides are not the same. These are different, so this has to be a rectangle. Okay, for B, I see all 4 sides have a length of 4, so they're all congruent, but we do not know if there are right angles. So this is a rhombus. Okay, next one, we see there are 4 right angles and all 4 sides are congruent. This one has to be a square. And the last one here, okay, these are all 90-degree angles, which are all right angles. If we don't know the sides, and also just looking at the sides, they don't even look like they're the same length, this is going to be a rectangle. Okay, next we have a theorem that says the diagonals of a rhombus are perpendicular. Okay, perpendicular, just a reminder, perpendicular means they make right angles. So do you see here, AC and BD, they make a right angle. And if there's one right angle, that makes all 4 of these right angles. Okay, and that's only going to be true for a rhombus and technically a square, because a square is a special kind of rhombus. Okay, ABCD is a rhombus. Find the value of x. Okay, so remember what I just told you, that there are right angles in here. So if I kind of just focus in on this triangle inside of the rhombus, and remember, a triangle is always going to add up to 180 degrees. So if I just take this triangle here and I say x plus 60 plus 90, right? Those 3 have to add up to 180 degrees. So we get x plus 150 equals 180. Subtract 150, we do get x equals 30. So that's going to be 30 degrees. Okay. We have another theorem, and this is about the diagonals of a rectangle. So the diagonals of a rectangle are congruent. Okay, now diagonals have to go across the shape. So from D to B, that's 1, and from A to C. And not only that, not only are they congruent, but remember, in a parallelogram, the diagonals also bisect each other. So that means in a rectangle, all 4 of those segments are going to end up being the same. They're going to be congruent. Okay, so let's take a look. EFGH is a rectangle, and it says find the value of x. Now this is a little confusing here because they're talking about EG is 12 and FH is x. So again, since it's a rectangle, x has to be 12. Okay, they have to be equal. Okay, quadrilateral ABCD is a rectangle. If AC, okay, so AC all the way across is 30 minus x. So this is 30 minus x. And BD, so this whole thing has to be 4x minus 60. We want to find the value of x. Okay, so again, diagonals are congruent. So I'm going to set 30 minus x equal to 4x minus 60. So I'm going to add x first. So we get 30 equals 5x minus 60. I'm going to add 60 to both sides. We get 90 equals 5x. Divide both sides by 5. So 90 divided by 5 gives us 18. So x equals 18. Just go back, make sure. Yeah, we just had to find the value of x. If they asked for the measures, we would want to go back and plug it in. All right, so now you're going to go and get the worksheet and do 6.4 worksheet.